So basically what I want to talk about is something that for me is quite an interesting topic, because I found myself in kind of recently, I'll probably say maybe 5 or 7 years, that I realized that I was thinking in graphs for a long time. It's just it had never clicked together. So I'm kind of going to show you how a lot of the things that we do are graph related, but also how even the organization and even things like integration and deployments, they actually are graphs, and we need to approach it as a graph. So clearly it's a presentation about graphs. So the interesting question is, why a graph, right? So why think of graphs? And the interesting part of the graph is graphs are a much better framework to look at the problem. And one of the things I liked about design is about a way where you refactor the problem until the solution becomes easy. Right? So in a way, you work at the problem, you keep working it until the solutions are easy. And if solutions are not easy, a lot of times it's because you haven't redefined the problem correctly. So, and graphs is an interesting example of that because it allows you to do it in a much more interactive and I would say real-world way, where you actually can almost take the messiness and complexity of your world and events and activities to actually make it part of your solution. So let's just look at a bunch of examples of what's a graph, right? So I don't think a graph is that, right? Okay, that's, you might sometimes call it a graph or a representation. In kind of in my head, graphs are like that. Graphs are more this, right? It's abstract data structures used to represent a set of objects and basic connections. So it's basically nodes and edges. That's how I think of graphs. It's about connecting things. It's about literally something that is connected to something else with attributes. That's basically my view of graph, right? So you can get really interesting about this. There's all sorts of graph theory, which is also a way that graph scales, because once you can get data into a graph format, there's actually a lot of great mathematics and thinking that already exists behind that. So that's actually really powerful in graph. So if you look at in security, we have plenty of examples how you have graphs in security. You have even things like attack trees, which are very interesting, and you can even visualize stuff like that, right? So even some graphs like this, some people might look at it and see a lot of complexity, or you might look at it and see a lot of simplicity. You might, depends what question you ask them, depends how you actually process the data. Threat models, for example, are a graph. If you look at what we do when you do a threat modeling, you actually are creating a graph, you're creating connections. You're basically mapping things out. You're going from A to B and understanding. What we don't do is we don't analyze this programmatically. Although, to be honest, some tools are trying to do so. The threat modeling tools are trying to do that. What the reality is, we actually need static analysis technology. So if anybody here is not working on static analysis technology, one of the still big missing tricks that we have is we need to start using that kind of techniques and capabilities even for more real-world stuff that we have, because this gets very complex very quickly. So the interesting thing is some of the biggest companies in the world are graphs. Right? I would even argue that the company I work for is a graph itself, because it's all about making connections. It's all about mapping things out. So Facebook, clear it is. Google, it clear is a graph. If you look at especially the things they do now with the Google graph and how, for example, if you search for a movie, you actually get much better connections. And also things like LinkedIn, they are clearly graphs, right? And it's an interesting thing that if you look at some of the biggest technology companies in the planet, and you look at their databases and how they structure, most of them are actually graphs, right? So clearly there's a nice kind of connection there, right? So the other part that is very interesting is ideas themselves are graphs, right? Ideas are these fragile little things that you have to basically be connecting and evolve and that can grow. So for example, this is my ideas for this talk. Literally, this is how I created the talk. I just did a massive dump, connected things, drew lines. This was my thinking process that actually got me to this. So it's very powerful when you start to view ideas as something that you need to collect and process and allow to grow, and you can visualize it as a graph and as a system. Now, if you go to Jira, and for example, and workflow, so I'm going to talk a bit about Jira and Confluence, just because it happens to be the platform that I happened to land. That was quite mature, so I end up using it. You kind of do this with some others, although it's a bit more difficult. So not that I'm representing Jira, but it just happens to be that the platform that I implemented in the current environment I'm in, and also the platform that actually allows me to do a lot of this stuff. So this is, for example, and I've done another presentation on this, how we manage risk. Right? So it's very interesting because you can see it's actually a graph. It's connected, and you'll see how this is almost like now in 3 dimensions once you add the other parts to it. So you got allocated for fixed, you got the beautiful accept risk button, right, which is what makes the whole difference. So if you're looking for a way to solve your risk management problem, you need a button that says accept risk, right? Once you do that, right, then things work. Until you have that button, you are always fighting uphill and you get ignored, or you get a lot of decisions made, right, but never kind of acknowledged or in the kind of ether, right? And emails and communications and meetings are not decision devices, right? A button to say, I accept this risk is a decision device. And then, of course, the security team, all the way to the CISO, has to accept and approve that risk. Sorry, the risk accepted then gets approved, right? But we do the same thing for tasks, we do the same thing for budget items. Basically, we go crazy, right? Like we literally are creating workflows after workflows after workflows, and we keep redefining them because we now view that everything we do becomes a kind of a graph, becomes a workflow, and you connect the dots, right? And that becomes very powerful. And of course, source code is a graph. Can anybody identify what I'm running here? Which tool I'm running here that's giving me the green dots? Really? Who programs here? Who actually works with programmers? All right. Who programs in JavaScript? Maybe. Okay. So this is a tool, right? It's amazing, right? And I found this spectacular. How even sometimes great ideas and really like something that you go, oh, this is it, right? These guys have nailed it. Yes, it sucks. It costs $100 or whatever, right? Because the freaking IDEs don't add it again. IntelliJ, is not free again. But this is basically a mathematical language, right? This is Wallaby.js, right? It's the only tool that will actually say that you have to use because it's the only tool that gives you the correct environment to write tests. What you have here is I have real-time code coverage and real-time test execution. Literally, I come in here, I change one of these properties, in milliseconds, my test will have run and will have shown me the results. Right? If you want to do test-driven development, or any development, you need an environment where literally you make something, or you make a change, you lift your hands, and the test runs. And this is also very powerful because it also means that I can go to the middle of the code, I can make a change, and it will run all the tests that are affected by that one change. So this is, it's crazily effective, and it still kills me the fact that every IDE has not jumped into the bandwagon, right? Because you'll see, I'll talk a bit later, we talk about testing things like the cloud and other platforms, like we are making the same mistakes again, right? We haven't even, we've always got to the point where we get the great development environments and we're making the same problem a bit further on. But you need to get this, right? You need to get the environment where every time you make something, you need to get immediate feedback. And immediate feedback is not on the screen, right? That's not immediate feedback. That is using your eyeballs, right, and your brains as a test. You need a repeatable way to verify what you just done. Without that, you will never scale. And security is important because this is how we should be testing security. So yeah, source code is a graph too. Again, you can do this. If you want to get even more interesting tests, you can start to write things where you go into the AST and you map stuff across, right? Again, right, I remember when I was working for Amps Labs. If anybody remember what that company was, right? They got bought by IBM, they became AppScan. I remember showing a graph like this that I was creating with the O2 platform. And I remember some guy saying, that's super complex, right? And there was another dude who was actually doing this manually. He says, that is the most simple thing I've seen, right? Because if that thing represents the attack surface, for example, he would spend literally a day or two to generate, a tenth of the quality of that mapping, right? So it's very interesting when you can start to program things. So I look these days at anything as an API, right? And if there is an API, I'm like one refactoring away from creating an API on top of that thing. Because once you get an API, you can program it, then you build a graph, then you're running, right? So Git itself is a graph, right? Again, I don't know how deep you guys got into Git, but it's very interesting. You should try to get in there because the way it works itself is a graph. The reason why Git scales is because the virtual file system that Git creates is actually a graph in itself. Nothing will make you understand better than Git and try to get that thing to work, right? But it's really cool, right? And even if you look at Docker, it's the same thing. I should have had that slide. Docker itself is a graph. The virtual file system of Docker is also hyper-connected, right? Like this. This is something I really want to play with. I don't know if you guys have played with this thing. I think it's really freaking cool. This is where you start to apply machine learning to some of these graph things. So, and again, for security, there's a lot of interesting parts of it. So finally, right, hyperlinks of graphs, right? The web is graphs. But one of the things that still doesn't happen enough is we don't hyperlink enough. So one of the things I keep always telling my team is that hyperlink, right? Make connections. And if you go to a point, I should be able to jump to the next one. Because every time you don't hyperlink something, it means that you just break a chain. It means it's less efficient to actually do something like that. Right? There's an interesting company called Neo4j. They have an open source part, they have another thing, but these guys have really been doing a lot of great stuff in graphs. It's quite a nice way. They have a really nice query language. And the reason why this query language matters, right, is because we also, so if you look at, for example, Visio, right, you could say Visio create graphs. Well, it doesn't really, right? Visio creates great snapshots of a graph. And one of the problems you also have is you have to be able to diff your graph. You have to be able to version control it. You have to be able to see it in time. So one of the very important properties of a graph is that you also need to be able to capture it in a sort of language format. And that's why I like things like dot language, like Plant2ML, and some of the others, because when you want to think about scaling your graph world, if you cannot code it, or you cannot represent it in a kind of a language-like format, then again, all you have is snapshots. It's a bit like it's the difference between playing with an image versus being an illustrator and playing with vector graphics, right? So it makes a big difference. So there's a lot of graph books out there, right? The one I would sort of recommend is that guy, right? It's kind of, again, it's a bit tainted for Neo4j, but it's the one that really clicked. It's the one that read that and they're going, I've been working in graphs for the last 10 years, right? I never realized it. Right? So it's really good, right? I think it has a really good sort of explanation of graph theory and how they connect and all this stuff. So I'll do that. I saw this great presentation a couple of days ago from these guys who talk about what Elon Musk taught me about growing a business, right? And the thing that Elon Musk said to him was, every person in your company is a vector, right? And the progress is determined by the sum of those vectors. So in a way, think about if you start thinking about a graph, the direction of your graphs and the connections of your graphs and how they go, that makes a big difference. So the analogy here is that, so if, for example, if you had 4 people, they might even be top level, that might be level 9, right? Let's say 1 to 10. They're all brilliant people, they are super, effective in their own world, but they align in their objectives. So you have almost zero impact. And sometimes this happens. There's 3 people aiming in one direction, one is aiming backwards, the other one's kind of going south, right? And eventually you don't have that suboptimal team. The best thing is when you have that, when you have the alignment of your efforts, your activities, and what you're doing, right? And again, in the team that you have. And this is thinking in graphs, right? This is thinking about the vectors, the connections, the way you actually align your environment. So I work for another company called Secure Innovation, where I was developing a product called Team Mentor, right? And this was very interesting, right? Because I was the lead development architect on this application, which kind of looks like this. It's kind of a knowledge base. It has, cool. It has like a structure here on the left. You got some filters, and then you got some results. So the idea, you pick something like this, you go like that, you filter there, and you get some guidance in the middle, right? What's interesting about this was that the first version was SQL-based, was database-driven, and this is the irony, right? Like, this was on a relational database, right? But the problem is, relational databases suck at relationships, right? They're not very good, because once they get to a certain level of complexity, you actually slow down, right? And then it gets interesting, because relational databases sometimes are not that good at key indexing searches, right? Then you have a nice hash-based database, so then you go, ooh, which database should I go, right? So, but what's interesting about this is that when we developed a new version, we took that model we had and we basically built a graph. And the way we actually did it is we evolved the graph into this. So what we actually did was, and there you can search, and even the search was very interesting because the previous search really sucked, right? And it was very interesting that when we revisit the search, having a graph, we were able to do very, very interesting stuff. We were able to do all sorts of weighted filters. We were able to game the system. We were able to pick certain queries. We were able to make connections much simpler way than if it was a relational database or if the data was not more properly normalized. So what I do for this is I start to visualize it like this. So that is what this looks like. So actually, these dots here are actually articles. That bit there is some of the errors. So this is another picture. But what you can already see here is, for example, here we had a whole bunch of areas that we had not a lot of articles. So it was really interesting that we even found a lot of gaps in our own knowledge base, for example, that were not obvious at all once we were not viewing the content as a graph. So it was really interesting that, for example, that is all the metadata. And this is a really cool way to draw a graph, because what you do is you use like a gravity. So basically what it means is each of those nodes is pulling each other, so they kind of have this sort of effect where it sort of visualizes quite nicely, right? So, and like for example, here's an example, right? Here's the type who maps to a checklist item or a guideline who maps to a bunch of articles, right? So this is a really interesting way to visualize it, and this actually helps us to design not only application, evolve the schema, and actually allow to do a lot of interesting stuff. And I'm not sure you can see this, but this is actually one article and all just the connections between those articles, right? And the thing I really learned about this was that when you do a graph, one of the mistakes sometimes I see is that you want to load it all in, right? It's almost like you want to build an Uber graph, right? You want to have this thing, especially now it's sometimes, it's quite cheap to create terabytes of stuff. It's like you freaking load it all in, right? And then you want to start querying on it. The problem is there's too much noise. So it's almost like the evolution of a graph is like even just the transformation of data into a graph-like format, it's already very valuable. In fact, that's part of your design. And what you then do is you create sometimes chain graphs. You do the first one that allows you to get to a certain state, and then you already can normalize that into another one. And the power of graphs is they allow you to do that. And they allow you to hyperlink things. So you can have a massive data store here that has some small connections to this other one, but it's very easy to navigate because graphs, you can fly through a graph very easily because it's almost like you're just doing key pair resolutions. So it was very interesting when we do this, and we actually can then think about how we want to see the data, how it maps, how the structure connects to each other, and how everything fits. For this one, just so you guys will know, we use this tool at the time called Level Graph, which is kind of based on triplets. So again, on graph theory, I really like this one. So it means is for every node and edge, you create a triplet, which basically means that you make a connection between these nodes, and actually that node and this node, and then the actual thing in the middle, which is basically the edge, right? So it's very interesting because it actually allows you, for every entry that you create, you can ask the question. So you can say, all right, if I go from here, where do I go to these guys? Or you can go to a node and say, actually, who connects to this? But you can also go on relationships. Okay, who has this relationship? And then give me all the nodes that map this relationship. So it's a really cool way of doing it. So it's basically, and it's one of those that it feels inefficient because you're creating free connections per item that you add, but that pays by itself every time you want to do a query. So it makes a massive, massive difference. And these things scale, right? It's very cheap to store this kind of stuff, right? So yeah, there's a triplet, and for example, there's the results, right? So here's a nice example of the kind of stuff that starts to get very complex because you go, hey, can I navigate by Matteo? Give me all the friends that are friends to him and the friends that are friends to that, and then you get that stuff, right? So, and you get to see the answer there, right? So that's basically, so the subject here is going to be the first node, the predicate is going to be the bit in the middle, so it will be friend of. So in the data you actually have something like, Matteo is friend of Danielle, right? And something like that. So, very powerful. I also use Viz.js to visualize the stuff, which is really cool. It's a kind of a JavaScript-based framework. What you can't see on the animation is that you can actually move all the little things. And sometimes those things make a little difference, right? The fact that you can actually zoom in, zoom out, move things around, right? Actually made a big difference. So it's quite cool, and it's actually JavaScript. So again, it runs super fast. So the logic we did visualization is we do the processing, that was spit a bunch of JSON, we visualize it on VJS. So now we get into Jira and Confluence, right? Now, in a way, so the first part is to kind of show that, there's a lot of graphs around, right? So hopefully you get the idea. One of the things that we do with Jira and Confluence is we use Jira as a graph database. Because you need to take a step back, right? So what do you want from a graph database, right? You want a place that you can throw nodes in. Like you want something, right? Let's say this guy, right? You need to be able to throw it something. Then you need to be able to ideally version control it so you can see the evolution. And then you need to ideally start to add some metadata to it. And so you can say this has some properties, this has some stuff to it, and you want to be able to link to another one with something that represents that linkage, right? So I can say this is related to that one, or maybe this risk fits that one, or this is a parent of that one. So that's basically what you want from a graph database. So it was quite interesting that I was using Jira quite a lot, and then one day I realized, actually, this is interesting. We're actually using it as a graph database. Because if you look at this, we have our global key, in this case, that's the risk, right? That's the global key, that's the unique identifier for this. And then we start to have labels, that's cool. We have extra attributes, so this is already attributes that we particularly added. You can then have the workflows, which already show the workflows. You can have assignments, you can have the timestamps, and you can, in this case, you have linked that to a particular epic. So this is a case where we had some infected machine downloaded a virus, right? Kind of typical sort of stuff that you get, right? So the interesting thing about this is that this is part of now an epic, right? And the epic now contains a pile of risks, but it also contains all the tasks that you've done. Now, some of you might already have a heart attack by the number of tasks that we have, right? So this is actually not even all of it, right? We actually have more, right? We just ran out of space at the end, right? This is every mini task that we create. So we're getting to the point where we're opening up tasks for questions because we are so efficient at handling that, right? Now, the point of doing this is, and that's the power of a graph, right? We got to the point where we have one incident which spins off the epic who tracks that, and they will create literally 20 tasks that come out of it. But they don't like, the thing about this is, you will all do it. The problem is you haven't normalized those tasks. They will be on somebody's head, right? And then it's a problem because you go, have you done this? Have you done this? Where are you? Where's the status? Etc. It becomes a nightmare to maintain. So because we actually have a team behind that does this, we get to the point where we open bazillions of tasks because we want to be very explicit with the questions that we ask. How have we done this? Have you checked this? Was the API data there? Was there this? Where was it? Blah, 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 etc. So we go very, very distinct because what we then do, and by the way, this is where you need to understand that, for example, Jira is great to hold data. It sucks at showing data, right? So you cannot use that. Like the problem with that epic is once you add more than 10, it becomes unusable. Because for some reason, the Atlassian guys decided that filtering this thing is not a priority, and I keep going myself to finding a bug and then going to the Atlassian mailing list and people asking for the last 10 years, and there's always a guy at the end going, really? 10 years to add this feature, right? So there's a pile of them, so this is one of them, right? So the point here is that you can't filter this, and you cannot do other stuff. But what we do is we do it in Confluence. So what we do is we actually create what we call these fact pages. And it's really, this is quite spectacular because what we now have is we have a real-time update of an incident, right? And we do this now almost every day, literally, for the incidents that we have. So, and you can see that you got, and we actually create executive summaries, we map stuff, you get the tasks, and basically, and there's all the mappings on here. What is really powerful in this is that this part here, which you probably can't see that much, is these are the questions that we want. That task response actually comes from, so I have another slide, I'll show that. So that task response actually comes from the ticket. So when we open all those issues, we have a particular thread about a specific issue, and then we have a specific field which is the task response. So if we think about it from a node point of view, who then maps here. So on this page, I can actually see the exact result. I want more details, I can click in here, I can go into there. So basically you can see that you use Jira as a database and you use Confluence as a way to view stuff. So here's a page where you actually see who's assigned to what and who's supposed to be doing what. So that page, for example, will show all the tasks that are pending and who's been assigned to that task. Which when you have a distributed team, sounds simple, but it gets very complex very quickly. In fact, I see a lot of places where you have these massive Slack channels, everybody's freaking piling on it, and it's a freaking nightmare, right? To even know where are we, who's done what, how can I help, what's the latest facts, what's the situation on this, right? And there's always somebody arriving late and going, hey, what's going on, right? And then the whole freaking thing starts, right? So this solves all that problem. The other thing that we do is we hyperlink our risks, right? So when we have a risk, basically we have the high-level risk, for example, insecure net access controls, who links to another level risk, which is insecure factory, who links to another one specific to the brands, who actually links to the vulnerabilities themselves. So what we have is we have this graph-based structure that allows us to go from one vulnerability all the way to the immediate level of risk that that implies, all the way to the business risks. And all these business risks will have to be accepted or allocated for fixed by the business. And the higher you go, the higher, in a way, the org chart, you start to see them. So the coolest thing of this is the high level risks are the ones that I will take to the board. Is the one that says, this is our global level of risk on the organization, and it's all fact-based. Well, this is very powerful because it means that when something changes, a new vulnerability, something happens, the entire tree gets affected. So this is very, if you think about it, you now have a graph-based vulnerability and risk-based management system, which is really, really cool. And any questions? I know you guys trying to get your head around it.
Is your dev open source?
Sorry?
Is your dev open source for this thing?
Well, actually, look, everything I've shown now, yeah, because this is released under Creative Commons, so there's no ID here that you can't use. So there's nothing, apart from needing Confluence and Jira, right? There's nothing you need for this, right? Else, right? Because up until now, I haven't shown you anything that's proprietary.
So that the actual screens or the things you actually made up?
No. This is just a view of on Confluence. Actually, you can speak to, you see the guys with this shirt here, right? And by the way, they're not insane, but we're hiring, so. But there's a bunch of people, actually, where's James? And Gemma, like there's James over there, and Gemma over there. Talk to them, they'll gladly show, right? You know, the way I look at it is that, they have my permission to share all this stuff, right? And there's actually an open source project that I'm doing for the next bit I'm going to show you. So, but to be honest, I think this is something that we should be working also as a community, right? Because I think there's a lot of cool ideas that, there's a lot of, I've seen, for example, other guys use, other teams using, for example, Jira in really interesting ways. I think we need to just share this a bit better. And I've done a version of this using GitHub, right? Which is also quite interesting too. GitHub, I quite like some of the GitHub stuff. It doesn't have workflows, but you can do the same thing with GitHub. For the other ones, I gave up, to be honest. Every time I see things like ServiceNow and some of the other ones, it's like, I just open one ticket, which is move to GitHub or move to Jira, right? because maybe the new versions do that, but it's just like, there's like 10 key features that they just miss, right? So again, so we can see that we use Confluence to view the data, right? So this is, for example, our status. We map all the risks. We can see where they are. We can see the status they're in. And this is kind of a nice picture, which is also here, of how we kind of handle our events, right? So what we do is we have an event that comes in. We create an incident. So this is already something that the business is already doing. So it's actually quite cool. We're actually already getting the individual devs or the individual team members outside security to open an incident, right? So literally they will open a ticket with the information. Even customer service is doing that, which is really nice. And then what we'll do is we have a dedicated team, which I'll talk in a second, but they do it straight away. They will create actually the epic that maps the whole thing. And then we start to map all the incident tasks. These are the ones that will create 20, 30, 40 per event. And again, the more the better, because actually the more granular you go with the questions, the more objective and the more focused you are. And the easiest to delegate. And then we have our hyperlinked version of risks. And then the magic of all of this happens when you capture this in the playbook. So the playbook, which is something that for the guys that went to the last summit, we start to work on it, becomes this sort of what to do. So the reason why we already, for example, opened 20 tasks straight away is because we already know, we already done some of these exercises. So we already know the 10 tasks or the 15 tasks that we want to do when this incident occurs. So this is where this becomes less of an art and becomes proper engineering, becomes proper processes. Where in reality is that I want to be in a situation where every incident that hits us, we already know the next 10 questions. And we already know, depending on where it goes, what are the next set of questions that we need to answer. So the playbooks, which is again something that we should be working together as a community, and I'm happy to share all this stuff, because again, we want to learn from everybody, and we collectively are much more strong. This is where the magic should be, right? This is where we should be normalizing. And this is also sometimes how you use certain tools. So, for example, on the recent WPA, the world is falling kind of, stuff, right? That happened recently. this was a good example, right? We mapped it up, we looked at it, some of the guys looked at us, and we created a whole bunch of stuff. So here's that example, right, of the task playbook that comes from here. Right? So for example, here's a question I asked. We use Darktrace. I don't know if you guys use Darktrace. It's quite an interesting piece of technology. The question that I asked was, will it pick it up, right? That was one of my questions. I want to know, like, because Darktrace is one of our early warning signs. I want to know, does Darktrace pick up this particular set of activities? I created a strategy which was based on 5 pillars. And you'll see again how this becomes a graph. So I have an enable pillar, which is all about enabling things. I have a prevent, which is about preventing things from happening. And enable is actually one of the most important pillars, because the way I look at it, security has to be an enabler for the business. Everything we do eventually has to become an enabler to allow either the dev teams or the ops teams or the business teams to make good decisions. So that's where we put all those efforts to do that. We have a trust where we put customer trust, but we also put things like GDPR. And by the way, if GDPR doesn't mean anything to you, you really need to take a look at it, because it's going to be a major change, right? And it actually, to be honest, it's actually a great way to also map a lot of these things. We have the detect, which is all about incident response and detect and response. So that's kind of our immune system. And finally, we have the educate, which kind of underpins everything we do, right? So where this becomes a graph is that we have these 5 pillars, and the pillars we've mapped to capabilities, right? So these are the capabilities. I'm sorry about the things. The screenshot didn't come out very well. The capabilities are basically what we want to build for these pillars, right? And then what's interesting is that we also then have the capability mapped to a program. So that means that if you take the prevents and you take the secure network, we have these programs of stuff that we do, and the programs are mapped to projects. So what you actually have is you have this really cool kind of world where you have a pillar who maps to a capability, who maps to a program, who maps to a project, and then, here's a project, right? So for example, something we do with the Hackathon guys, which I think are here, right? We want to do some developer hackathons and guidance, right? You can select from the drop-down box which pillar you are, which capability, which program. So you can see that we actually use Jira to manage the projects themselves, right? And then we create something like this, right? Now what's really cool about this is that this all comes from Jira. Can you guys see how the pillars map? So there's the pillars, there's the capabilities, there's the programs, and there's the projects, right? What is very interesting is that it was only when I created this view that I could actually understand what the hell we were trying to do, right? Across the entire security group, right? Because it's only when you can kind of visualize data like this that it becomes consumable. Like even this graph, if you can, even this table here, right? If you cannot normalize it like this, it becomes unreadable. You can. You have like 30 prevent things there, right? And then the problem is if you do this in Excel, you'll be out of date the moment you do it. Like we did this. We had a version of this in Confluence. It was out of date within probably like 5 hours, and within 3 days was already totally kind of forked. So it doesn't work. So, and the coolest thing, you also get a view like this, right? So this is another view where, again, all the data comes from Jira, but can you see how I was able to map the data in a way that I consume? I even asked with a budget thing, there's a magic kind of field in there that allows me to map this, and you even map the risks that are mapped to that project. See, so this is how the thing works. You get a vulnerability that we found, we map the risks. The risks now map to a project, it maps to a program, maps to capability, maps to a pillar, right? But you then see the whole thing connected. The reason why you do a project is because the project fixes risks. That's why you fund the project. It's that simple, right? And then when a new risk comes along, the question is, do we have a nice project to step this in, or is not even on our roadmap, which is a much more worrying problem. So how I did this, I basically created, this is what you do, right? So the way, my view of the world is I use whatever technology the company has, and for everything else I use Jira and Confluence. And the moment I start to ask a question to Jira and Confluence, where I'm like one of a bunch in the world that there's no answer for, or there's no easy solution, I write a script for it, right? I program it. And that's what you have to do, right? Because there's a time where the tools just cannot handle. Like, for example, to map this is really hard in Jira, because you are 1 degree of separation away, right? So if, for example, you talk to James, he's been trying to do this with Jira, right? And his head blew up a couple of days, right? Because you just can't, or it doesn't scale. right? So the way you need to do this is that this means that I'm asking, give me all the risks that map to this project that have a particular severity. It doesn't work because you actually have things mapping into it, right? And it gets even more interesting when you go, show me the residual risks. And then if you even go on higher, because I want to go to a pillar and I want to see all the risks that map to that pillar. Because that's what I report to the board, if you think about it. Right? What the board wants to see is the pillars, maybe the capabilities, right? And they want to know what is the status of each one of those. And it has to be mapped by reality, which basically means that it needs to be mapped to projects, it needs to be mapped to risks. So here, you do this. So this tool, which I'm running CorpusScript, allows me to create this. Right? And again, it's open source, you guys can get it from there, right? Please contribute, right? So what this tool does is pretty cool. It actually, there's two modes. One mode, it dumps all the data from Jira into a nice JSON file, right? And then do some processing. And the other one is actually consuming Jira in real time. I haven't got to the point where I'm actually updating Jira, because I want to do a bit slower, because I do have the fear of basically, fat fingering a query and then deleting half of the freaking Jira stuff, right? So I haven't got to the point where I'm actually doing updates from the tool all the way to Jira, but that's coming next, right? But even just being able to create views like this makes a massive difference, especially this one. So again, come as a graph, everybody's connected to everybody, interconnects is fundamental, and we are basically part of this, right? So that's how everything maps together. So one of the things that's interesting is that how do you know your team is working, right? So one thing that's very important is when the team is actually doing stuff that, like, well, look, you know the node system is working when new nodes are being created without the main drives pushing it. That's when you know the system is working. That's when you know it's scaling. And even when your team crashes the system, when they blow up the graph, it's cool, right? Because that's part of the evolution of it, right? So one thing that's interesting is that, exactly, if you don't use Jira, how the hell do you keep tasks, right? But so one of the things that we do with Jira or with tasks, I mentioned this before, you have to capture and hyperlink everything, right? If you don't capture a task, you will lose it. That's why my default is put everything in there and then we manage. The interesting question is that you need a team of humans to manage this, right? I think that the biggest mistake most teams do, even development teams, is they don't allocate enough resources for the maintenance of these systems. So we basically have two remote superstars, right? Some of you guys probably met them from the summit, Anne-Marie and Robert. Their sole job is to maintain Jira and Confluence. That's all they do. That's why we scale, right? But without that, it doesn't scale. And the reality is that when you look at the cost of those resources, compared to sometimes the overhead you have on your team, it's very low. But you need to have that. Because if you don't have that, you actually won't manage, right? So again, what they do, and so what that means is you have a lean operation team because they maintain the graph. So the thing about graphs also is that they have to be maintained, right? That's in a way, that's the key message here, right? And in a way, that's, I would say, a key element of all this. So one interesting thing about this is that you should have, and one thing I do is like again, when you have an ops team, make sure that you empower them, make sure you give them a budget, if you want to do training, all kind of stuff. I just view it as a graph, right? Again, even the budget is just a graph, right? You want to make sure you delegate it to the right elements. Basically, and finally, just to speed up the final part, right? One of the things that is also very important, and I find myself having a big allergy to this, is things that break a graph, right? So, and this is very important because the same way that sometimes it's very hard to predict the unintended consequences of things, I've learned that if you create things that break graphs, you are preventing a lot of future events from occurring. And sometimes the immediate events might not be that significant, but there will be that line, that continuum, that you might come back a year later going, wow, this happened because of this, because of this, because of this, because of this. The OAS Summit, for the ones who guys went, occurred because me, Francois, and Sebastian met at the same place and made a connection. And were able to immediately sped with that graph and make it scale, right? So it's quite powerful. That's why I like the open source stuff, because you expand and unbroken graphs can actually grow quite dramatically. So Avaton, for example, that I was talking about, great example, they open source their engine, right? So they actually did this at the summit. Now, there might be a situation where maybe not that much has happened since, but in terms of maybe like big developments, but the connections that have occurred are going to be significant. So this is the thing. If they haven't done this, they haven't broken the graph at that moment in time. right? So, but this is hard, right? It took them a bit of convincing and energy, right, to do it. But I think it makes it much better in the medium term, right? So again, in DevOps, it's quite interesting, right? Because the way I look at it is that what we're doing most of the times, we're actually pushing faster and faster these stuff. So that means we're pushing problems faster and faster into production, right? And what we need to think of is we need to think of the CI pipeline as a graph, which actually means that we need to freaking start writing rules for our CI, right? Our CI is an application itself, right? If you don't test your CI, if you don't test your CI with rules and with tests, you don't have a repeatability, right? So your CI is an application, so you need to have tests. Unfortunately, we don't have big test APIs and environments for it, but you can create them, because you can create a DSL for it. But this is actually something very important, or else all you're doing is automating this thing that is actually pushing code and systems all the way faster, but you still have a lot of fragility in the system. Finally, if there's any recruiters here, if you guys think about this, the way I look at it is that you need to think as a graph. So what I would like to see from candidates is things like GitHub, Twitter blogging, contribution conference, open source collaborations. This is a graph. I want to see the graph of the candidate, right? And you can even do interesting stuff, right? There's no reason why they should behave as they already work for the company. They should be able to hack it, find vulnerabilities, collaborate, right? And be involved, right? That's how you get to work for a great company, right? Because you should be there. So it's about building that graph, right? So the first recruiter that sends me a graph of a person, I guarantee you that will call you back, right? And basically, and that's the flow, right? Finally, I want to give you an idea how you can turn a problem into a solution. This is something that we work in Chiswick. Actually, my wife is working on this, where they're trying to fix this, right? This is one of the bridges. This is the map of Chiswick, right, where I live. So you can see that it doesn't work, right? So the problem is you have a square to go into a rectangle, doesn't freaking work, right? The solution was to turn the problem into the solution. So each square represents a timeline. So you've got literally, this is like 1800 all the way to A to Z, right? So it's a cool example of using design to take a problem and make that part of the solution, right? So there's a summit. You guys, if you weren't there, you missed the trick, right? We're doing another one next year. Here's all the outcomes. There's a great book that came out of it. The final thought of this is that we need to start working together, because as the criminals, as the whole thing evolves, this is going to get much worse, right? And we really need to start collaborating. And there's some really cool ideas like the OXCDC, which is the Collective Defense Cluster, and all sorts of things of collaboration. I think we, as an industry, need to really start sharing and collaborating a lot more of the ideas that we're doing, because things are going to get a lot more tricky, right? And I think there's an interesting move of a lot of also interesting professionals who are going to the defense side of actually trying to solve these problems, and we really need to leverage that, because that's basically how we will scale. And thank you.